So this is problem number 25 from growing investigation number 4. It's kind of an interesting problem, something you probably don't think about a whole lot. Freshly cut lumber, known as green lumber, contains water. If green lumber is used to build a house, it may crack, shrink, and warp as it dries, which causes lots more problems because then you have cracks all throughout your drywall and it just does not look good. To avoid these problems, lumber is dried in a kiln that circulates air to remove moisture from the wood. Suppose that in 1 week, a kiln removes 1/3 of the moisture from a stack of lumber. What fraction of the moisture remains in the lumber after 5 weeks in the kiln? All right, so here's how I would do it, and I'm probably going to answer some other questions as I go. Actually, more specifically, I'm going to answer this question first. Life would be a whole lot easier if I had an equation and a table. So that's what I'm going to make. If the kiln removes 1/3 of the moisture, then that means 2/3 of the moisture remains. Therefore, I know that the moisture remaining is going to be equal to 100, which is 100% of the moisture. I'm dealing with percentages, right? 100% of the moisture times my decay factor. Well, if my decay rate is 1/3, my decay factor will be 2/3. And that will be to the power of the week. Great. And so let's make my table. My table is going to have weeks. I'm going to 5 weeks. And I have moisture remaining. And so after 0 weeks, we have 100% of the moisture because that's the way it came in. After 1 week, we'll have 2/3 taken out, so we will have 67%. I'm going to round to the nearest whole percent. And now, if I have 0.67, or 76%, actually let's just keep it in a percent, and I'm going to multiply it by 2/3, 2/3 being 0.66667. Then I will have, and again I'm rounding to the nearest whole percent, 45% of the original moisture remaining after 2 weeks. After 3 weeks, I will have 30% of the moisture remaining. After 4 weeks, I will have 20% of the moisture remaining, and after 5 weeks, I will have 13%, and just because I'm being a little proactive, and I believe that 13% moisture still may be a little bit on the high side, I'm going to go to a 6 week times point. And now we're down to 9%. All right. So what fraction of the moisture remains after 5 weeks? Well, after 5 weeks, we're at 13%. What fraction of the moisture has been removed? Oh, so this is moisture remaining. And let's have moisture taken out. Sure. So how much of the moisture has been taken out at 0 weeks? Well, 0. After 1 week, we have had 33% taken out. After 2 weeks, we've had 55% taken out. After 3 weeks, we have 70% taken out. After 4 weeks, we have 80% removed. After 5 weeks, we have 87% removed. And then here we have 91% removed. All right, so how much has been taken out after 5 weeks? Well, after 5 weeks, we have 87% of the moisture removed. Write an equation for the fraction of moisture remaining. Oh, well, okay, so that's right here. Write an equation for the amount removed. Okay, well, if we have 2/3 remaining, what do we have taken out? 1/3. So, well, what did I do here? So I had my 100%, then I used the equation, and then I subtracted that from 1, or in this case 100. So my equation for that is going to be 100, because that's what I started with, minus 100 times 2 to the third power, sorry, 2 thirds to the w power. And so this will be equal to, why do they want us to use m twice? How about m subscript out and m subscript in to keep track? Graph your equation from parts C and D on the same axis. All right, well, let's go ahead and do that. So I am going to pull up my handy dandy graph. It's almost like magic. You're a wizard, Harry. All right, so let's go ahead and graph the green. So at 0 weeks we have 100%. After 1 week we have 67%. After 2 weeks we have 45%. After 3 weeks we have, after 4 weeks we have 13. After 5 weeks we have, oh shoot, after 4 weeks we have 20, my bad. After 5 weeks we have 13. After 6 weeks we're down to, and since weeks we can have fractions of a week, we should probably go ahead and connect the dots. Oops, it's like my pen wanted to jump over that spot. And then let's go ahead and do the purple giraffe. 0, 0, 133, 2, 55, 3, 70, 4, 80, 5, 87. All right. And now the interesting kind of cool thing about this is it is symmetrical about just about that 50% line, isn't it? That's kind of neat. All right. All right, so moving on. A different kiln uses, removes 1/4 of the stack. So we need to do the same thing again. Yes. So I'm going to use red. So we have weeks, we have moisture in, moisture out. And I'm going a little bit farther because if we're only taking 1/4 of the moisture out, that's less than a third, and we need to get to 10% or less. So I know I'm going to have to go farther. And so let's go ahead and pull out the calculator. So 100% times 0.75. Shocking! It's 0.75 or 75% times 0.75. I'm going to round to the nearest whole percent. And we are just continuing. I hope we get under that 10% on this one. Oh, well, rounded to the nearest whole percent. We're at 10% or less. Excellent. And so, same idea here. So we have 0 taken out, 25. I'm subtracting this from 100, so that is 44. Here we have That's embarrassing. Oh my goodness, what's going on? 58, 68, 76, 82, 87, and 90. And so at this point, I'm not going to graph that now, but you just graph the points, and you'll have a graph that looks very similar. Actually, you know what? I do kind of want to graph this. So what I'm going to do here is just to make my life a little bit easier, I'm going to select this. I'm going to remove it. Hopefully I didn't lose anything I wanted to keep. Nope. I'll select this, and I'll remove that. And hopefully, if I've done everything right, I can move this up. All right, excellent. And I wonder if it's going to be symmetrical about that 50% line again. I'm curious. So at 0, we're at 100 again. That's not the red pen. So then 175. 256, 342, 432, 524, of course I go off the page, 618, and I'm not going to continue here. We know what happens. And then in the blue, we have, let's connect the dots. And then in the blue, in the moisture taken out, we have 0, 0, 0, 125, 244, 358. Where's the 58? Right about here. 432. Oh, sorry, 468. 524. 5. I keep looking at the first one. 76. 682. Let's connect it. Oh, you know, if I think I drew this better, I think we'd be on that 50% line again. That's really kind of cool. All right, so finally the last question. Green lumber is about 40% water by weight. The moisture content of lumber is used to build houses is typically 10% or less. For each of the two kilns described, how long should it take before it is used to build a house? All right. Now it would be wonderful to just use this table and just say, okay, here's my 10%. But we're starting at 40%. Great. So that means in my equation, if I have 40 times 2/3, the W power, I'm using the first one. All right. So 40% of weight times 0.6 repeating. That's going to be after 1 week. We have 27. After 2 weeks, we're at 18. After 3 weeks, we're at 12. So clearly it's going to be after 4 weeks they can use it. For the other one, same idea. We have 40 times 0.75. So that's week 1. That's week 2. That's week 3. That's week 4. It's going to be week 5. So it'll take 1 extra week. All right, so there you have it.